Hi friends, today we're going to finish up on last week's episode on intervals. Here we go! As I mentioned in the last episode, the major scale is used as a reference tool to help determine intervals since it is the scale most people are familiar with. If you are not fluent in your major scales, I would highly suggest reviewing Music Mechanics 10. Now, suppose you run across a curious instance of an interval such as D sharp to B. Technically speaking, there's no such thing as a D sharp major scale since it would contain double sharps, and it's much easier to just write the E flat major scale. How would you determine this interval? Easy. Rewrite the exact same letter names of the notes in this interval but without the accidentals. This results in D and B. Looking at the piano keyboard, you'll notice that going from D sharp to D results in the key on the keyboard moving down a half step. In order for us to keep the same interval ratio as D sharp to B, we must change the B so it descends down the piano keyboard a half step as well. This can be accomplished by adding a flat to B. Now, if we look at the D major scale, we can determine that D to B flat is a minor sixth. Since the interval distance has been maintained when we change D sharp and B to D and B flat, we can correctly determine D sharp to be a minor sixth. Like whole steps, W, and half steps, H, each interval quality has a corresponding shorthand notation, shown here. Note that diminished is notated with a small d, while augmented is notated with a large A. This is presumably because the overall effect of a diminished interval symbol is to diminish or make smaller, while an augmented interval symbol is meant to augment or make larger. The small d and capital A are used in academic circles primarily, as the small circle and plus sign are the most commonly used symbols. Our interval formula now looks like this with shorthand notation. This interval formula with its corresponding shorthand is visibly demonstrated in the following musical example. All examples use C as the low note for comparison. Observe that two of these intervals sound the same but are written differently, the diminished sixth and the double augmented fourth. These are enharmonic intervals. The notes of an interval can be played at the same time or one after the other, depending on how it is written. Take a look at these examples. Notice the notes in example 1 are stacked on top of one another. This means they are to be played together at the same time. This is like a chord which will be discussed in a later episode. Example 2 demonstrates an interval with the same two notes from example 1, but presented one after the other in a melodic fashion. Both examples are intervals, the first example described as being played harmonically while the other is to be played melodically. They are also sometimes described as being presented or notated vertically versus linearly, or the less used term horizontally. Linear intervals can be further academically described as either steps or skips, where a step would be the notes of the interval presented on any adjacent line in space or space in line, and skips constituting everything that isn't adjacent lines and spaces. Stepwise and skipwise motion are interval terms primarily used to describe the character of melodies. This example demonstrates the most common ways of writing all the intervals available within one octave, using C as the low note for comparison. There are alternate academic terms for some of these intervals. For example, a perfect unison, P1, is called a perfect prime. It's a relatively uncommon academic term. A minor second is often referred to as a half step or a semitone, while a whole step can be referred to as a major second or a tone. A very rare academic term is a ditone, which is two whole tones or whole steps stacked on top of one another, which is synonymous with a major third. For example, C to D is a whole step, and D to E is a whole step. A tritone is a fairly common term for three tones stacked on top of each other. For example, C to D is one whole step, D to E is another whole step, and E to F sharp is another whole step. Three tones, or major seconds, stacked on top of each other equals a tritone. A tritone, also known as an augmented fourth or its enharmonic equivalent, the diminished fifth, evenly divides an octave, so stacking one tritone on top of another will sum up to one octave. Up to this point, we've been dealing with intervals within and including the span of one octave. These are called simple intervals. Intervals wider than one octave are called compound intervals and can be determined in almost the same manner as intervals within one octave. Determine the interval number by counting lines and spaces from the low note to the high note, being sure to include the low note in the count. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. In this example, the interval number was determined by counting to be an 11th. The interval quality of an interval greater than one octave can be determined by dropping the high note of the interval one octave down and then determining the interval quality from the root to the high note dropped one octave. Let's begin by dropping the high note of the interval down one octave. Now determine the interval number by counting from the root of the interval to the note that resulted when you dropped the high note down one octave. In this instance, the interval number from the root of the interval to the note that resulted when you dropped the high note down one octave is 4. Next, determine the interval quality by constructing a major scale starting on or from the low note of the interval as the root. Count or play up the scale using the root as the first count and stop when you get to 4 notes, the same number as the interval number calculated from the root to the high note dropped one octave. In this example, the low note is C, and so we will write a C major scale. Begin counting or playing by starting the count with the root and stop when we get to the 4th note. So here's C, and we just go up 4. 1, 2, 3, and 4. The C major scale has an F natural for the 4th scale degree. However, our interval in question has F sharp as its high note and does not match the note found at the 4th scale degree of the scale built from the low note of the interval, the C major scale. We now consult the second half of the interval formula to determine the interval quality for unisons, fourths, fifths, and octaves, since the interval number is a fourth. According to the interval formula, if a fourth is in the scale, it's called perfect. However, the high note of the interval in question, F sharp, is not an exact match with the note we stopped at in the major scale, the 4th scale degree, or F, so we must take what normally occurs in that scale, F, and alter it by adding or subtracting half steps with sharps or flats until it matches the high note of the interval in question. In this instance, we must add a sharp to F to match the F sharp in the interval in question, thereby adding a half step higher to F and turning it into F sharp or an augmented fourth. Again, according to the formula. When a sharp is added to F, it increases the distance from the low note of the interval, C, to the high note by a half step. This changes a perfect fourth to an augmented fourth. Therefore, the interval that resulted when we dropped the high note one octave is an augmented fourth. Our original compound interval has an F sharp as the high note. When we drop the high note of the compound interval down one octave, it becomes a simple interval with an F sharp as the high note. The interval number of the original interval is an 11th. Since an 11th is simply a fourth one octave up, the rules that apply to a fourth also apply to the 11th. Therefore, our original compound interval is called an augmented 11th. The interval quality of an interval greater than one octave can always be determined by dropping the high note of the interval one octave down and then determining the interval quality from the root to the high note dropped down one octave. This table shows what each interval above one octave becomes when dropped down one octave. The interval quality of a ninth, for example, can be determined in the same fashion as a second since it is a second one octave higher. Simply drop the ninth down one octave, making it a second, and determine the interval quality of the second, which will then tell you the interval quality of the ninth. Here are the most common intervals wider than an octave commonly seen. Become familiar with them. Hey, thanks for watching the video. Be sure to like and leave a comment below if you have any questions. And don't forget to hit the subscribe button. If you like the music you've been listening to, please be sure to check out my friend Leslie Page's album, Heart Songs, at this link.
Was it how I